Hi, Assalamualaikum and greetings to everyone. My name is Siti Nurhana Nazira binti Muhammad Latif, and me and my group will be presenting a topic which is known as Introduction of Periodic Trends of Elements. So let's get started. So first of all, we will be starting our discussion today with atomic size or radius. So for this, we will be observing our periodic table by two ways, which is across a period and going down on a group. So for across a period, the size of atom will decrease and the effective nuclear charge, or known as ZAF, will increase, and also the number of valence electrons will also increase. This will make the attraction between nucleus and the valence electron getting stronger. And for the going down on a group, the size of an atom will be increasing and the electron will be added far from the nucleus and will make the attraction to get weaker. And the shielding effect will also be increased because of the additional inner orbitals. Next, we are going to talk about electronegativity. And for across a period, each element across a period will contain one more proton, and more proton means more power to attract electron. This will make electronegativity to increase. And for down on a group, atomic number will increase, and atomic number the increasing of atomic number will increase the distance between electron and nucleus. This will make less power to attract electron, and the electronegativity will decrease. And furthermore, we will be discussing about ionization energy. So what is about ionization energy? So for a Corsa period, the atomic size of an atom will decrease. So the outer electron will be moved closer to the nucleus and will make the attraction to be stronger. And this will make the ionization energy to increase. And for down on a group, the atomic size of an atom will increase, and the outer electron will move far from the nucleus, and the attraction will be weaker than across a period. The ionization energy will decrease. And lastly, we will look at electron affinity. And for across a period, the electron affinity will increase, and for down on a group, the electron affinity will decrease.
Hello, I am Hani, and now we are going to move on to the problems to demonstrate the application of the periodic trends itself and their influence on the material properties in a real world context. So, actually, there's a lot of problems and cases that are related to the periodic trends. Jewelry is one of it. So, let's take platinum and gold as our example. Okay, so here's the general difference between platinum and gold. Both platinum and gold actually is in a transition metal group, but as you can see, platinum is in group 10 while gold is in group 11. There's also a difference in the atomic mass number, which is 78 for the platinum and 79 for the gold. Okay, so the platinum usually is softer than gold, meaning the platinum is easier to shape, but it scratches easily. Compared to gold, it's denser and heavier, meaning if we wear gold, it gives the jewelry a heavier feels, and the gold itself actually have the higher durability. So let's take a look of the material properties difference between platinum and gold. But first, please keep in your mind that platinum's atomic mass number is 78 while gold is 79. So let's move on to the electronegativity. So, as we all know, down to the group, electronegativity decrease. So, the platinum is lower in charges for the electronegativity compared to the gold, which is gold is higher. Okay. Next, atomic size. Atomic size is perpendicular with the electronegativity, like this. So, the atomic sizes down on the group, it will increase. So, platinum has bigger atomic sizes compared to the gold. Move on to the ionization energy. Ionization energy is parallel with the electronegativity. So, the ionization energy for the platinum is lower, while the ionization energy for gold is higher. Next, we move on to the corrosion behavior. Actually, both platinum and gold is high in corrosion behavior, But since gold is technically more chemically inert in most environmental situations, so it makes the platinum is higher in corrosion behavior because platinums can maintain the stability in the chemical reactions. Okay, so move to the alloys. The alloys for the percentage of alloys or types of alloys in platinums can be defined by the carat and the color variation of it. Usually, the platinum's alloy is a mixture of high purity platinums. About 90 to 95% of platinum itself mixed with iridium. It makes a good platinum alloys. Okay, for the gold alloys can be defined by the density and the durability of the product lah. So, usually gold's alloy were alloyed with an rhodium elements to make the gold more shines and beautiful. That's all.
Hello, my name is Rehana, and my task is to explain to you guys the challenges that we might face in our everyday life in this topic, and also the solutions for it. There are a few common challenges, and one of them is the safety risk. So, safety risk is related with the reactivity trends when the elements going down the group, the metals like alkali metals or alkaline earth metals becomes more reactive because the atomic size is getting bigger. So, when this happens, uh, alkali metals like potassium will react vigorously with water and causing it to explode or also producing flames that can injure the handler. So, in order to prevent any injuries occurred in the laboratory, these metals, such as potassium and sodium, should be stored in the paraffin oil to prevent them to be reactive and can be safely handled. Next challenges is energy consumption. So energy consumption is related with the ionization energy trends. What we have learned is in this chapter is when going across the period, the size of atom decreases to strong attraction between nucleus and valence electron, making the removal of electrons harder. In order to remove the electrons from these elements, we have to use high level of energy. For example, the production of aluminium, which use smelting method that involve electrolysis, a process that consumes approximately 13 to 15 megawatt hours of electricity per ton produced. And this high amount of energy use is not really good for the environment. Thus, we have to find the better solution for it. In order to reduce the consumption of energy, we have to recycle the aluminium that was produced to reduce its production. From this alternative, from this solution, we can actually use less energy and also can minimize its impact to the environment. Next is corrosion. Corrosion is what we actually face often in our life. It relates with electronegativity trends. From this chapter, we have learned electronegativity is the ability for an atom to attract more electron in chemical bond. And we can summarize the higher the electronegativity of the element, the harder for it to lose the electron. I'm going to give you one example, which is the galvanic corrosion that occurs when two metals that have different levels of electronegativity binds together and reacts with water. The findings showed that the metals that have the lower electronegativity will corrode faster than the other. It is because When the oxygen reacts with the lower electronegative metal, it will attract small electron and cause it to be corroded. Thus, to prevent the corrosion to happen, we can use metal plating such as zinc plating uh, that acts as a sacrificial protection, and also paint uh, which can help to block the moisture, salt, water, and oxygen to penetrate through the underlying metal.
Assalamualaikum. My name is Nur Alana Sulha binti Sa'ad. My metric ID is 2025468862. And my role in this presentation is presenting the conclusion. Periodic trends such as atomic size, ionization energy, and many more from across a period and down on a group play a big role in determining the properties of an element. The trends conclude why certain materials have different reactivity, strength, melting point, and many more. Different type of element create a different kind of problem, each. As an example, platinum and gold. The two have different kind of trends, thus creating different kind of physical properties, which also contribute to real life situation. Each properties have their own uses that are specifically applied in different areas. There are tons of obstacles that normally occur while conducting various types of material, such as safety risks, solubility, and many more. Understanding the periodic trends and applying chemistry, physics, science, and technology knowledge can help overcome the challenges. Thus, allow us to connect the atomic structure to material properties better. That's all from me. Thank you.